there were only a few emails sent out. So
Yeah.
I was like, what's that?
Well, when the router dies completely, then if ping doesn't come back from that thing, then it only sends one.
Yeah.
Temperature high again.
It seems to be mostly working, except maybe it was just really hot today.
It wasn't that hot. I went for a walk at lunch. It wasn't that hot.
So I don't really know.
Yeah.
Well, all these other days, the phone servers were down. Having some days.
Oh, okay. That's probably why. Is it just... Hello. Yeah, it just went really not far. Barely. And then it was going down and up.
You end up going
Oh yeah. See my email, I said I was coming the next day.
yeah.
Is he getting drunk?
Yeah.
He likes to do that.
What?
He likes to do that.
Oh yeah. Comes out. Now it's like, oh, I don't think it's
Wow.
that's pretty Did you see he came out with a statement today? Yeah. Like, basically, so I guess that, you know.
Hey, is anyone familiar with using OBS to live stream?
Go for it. Oh, anybody familiar, you said?
Yeah, for some reason, when I normally run this webcam sitting here, if one who's here, I get the entire picture. Now, when I'm running here in, with OBS, it's just getting like the center of the picture and leaving out most of the video. I don't know why it's doing that.
Interesting. I've never used
I used
OBS.
it a little bit.
Yeah, this is like the third time I used it. Every time it takes me almost an hour to get it working.
I've wanted to play with it before. I haven't gotten around to it.
Interesting.
Is there input settings? I have the same camera. It's zooming in. That's also why it's blurry.
What's that?
The camera, it's
Yeah.
zoom in.
Yeah, I don't know why it's doing that. And I have no idea how to change that. I don't see anything obvious up there.
Maybe the this one? The little gear icon there, maybe?
So it's
Yeah, looks like
capturing
it's
it
not-
fine.
it's not
It's
coming through
the
this.
so the capture settings are fine. It's the
Just this display.
so the red line going out of the frame. It's only displaying or capturing the corner of the video. So if you click on that thing, there
You
should
need
be
to close that first.
yeah, you can close that up. Yeah, that needs to be scaled to the size of the output.
Oh.
It doesn't seem to be doing much or anything,
It's
other
just
than
moving.
moving it.
There's some properties for that. What's the
Actually,
input
it's the
properties?
same.
There must
There was a
be
lot of stuff on when you right clicked that looks some of it
Oh.
might have been interesting.
Let's maybe
I wonder if
preview.
it has to do with this dimensions of the
Scaling, I don't
phone.
want to scale it.
There
Because
you
it fits
go.
on the phone.
No,
didn't
that's
change
the output viewport. But
How about the canvas? In the previous scaling
Canvas,
one?
where's that?
Up here. Yeah, good. Try canvas or output. Oh, yeah, okay. That one's even worse.
well, no, because the canvas.
It's like the same thing, just only zoomed a lot bigger.
Yeah. What's the other option?
Output.
Output. So in the output settings,
Okay, so the
what do
question
you
is
have?
Oh, looks like it never stopped streaming either.
mm-hmm. So
Okay. That's obviously not doing it in real time.
Although Richard Spencer did get maced and arrested, so that's always nice.
Okay. Okay, I've got the guest list coming around. Let me start it with Ben.
It's been so long since I don't use this. Try edit transform.
Edit.
First one. Okay, so that, yes. So if you lower the size of the output, different size, you enter.
It's like 110.
600 or something.
And now position, you can put it to 0.
There's something that was like stop putting shit on the internet.
Oh, that's better. Okay, thanks. So you should cut up.
I guess we're officially on a question and answer period. Any questions that are somewhat Linux related?
Are you giving the talk?
What?
Are you the one giving the talk?
No, Federico is. He's downstairs somewhere.
All right.
Apparently, Debian celebrated his 24th birthday.
What?
Debian celebrated its 24th birthday.
Okay.
Heck, that's older than our group. Our group's only 23 years old.
I'm trying to remember the name of my first Linux distribution. I was running SCO before that. Yggdrasil.
Slackware?
Yeah. Yggdrasil was my first Linux distro.
The first one I ever tried was SLS. I couldn't get it up and running. And then someone told me that SLS was broken and recommended I try Slackware instead.
First distro I ever tried, I think, was damn small Linux. It was essentially I was using a shared computer at like the YMCA, and somebody was like, "Oh, you should try this Linux thing." And it opens up in like a QEMU like window and this, that, and the other thing. Tried to use it on the school computers. They were like, "Hey, don't do that. You don't." I'm like, "It's not gonna change. It's not gonna like modify anything. Like, don't do it." I'm like, "Okay."
I used to do mini install tests at Northeastern with my class,
Yeah.
my Linux class.
How about Linux? Does that count?
Yeah, a lot of people have these weird superstitions.
Linux
I
was
remember one time,
actually
one time there was a
Linux was
presenter who
built
was
on
showing some
Linux
kind of
originally.
video camera for the Macs. I think it was like in '84 or '85. So I pointed at the screen of the thing, to give this weird effect, and this guy just flipped out and started screaming that I was going to blow up his equipment. As if the camera somehow would know that it's looking at itself and then have a nervous breakdown.
And the computer science.
Yeah, my first was interested because Mad Dog suggested that,
I don't know, I played with
Had
James,
the,
it was like the first one
DVDs.
really
or that's,
Was it
they
because
didn't have
you saw
DVDs,
someone on
they only had
4chan
CDs.
recommend it?
No, floppies.
It's like I tried this the
First time that
the
I,
Triforce thing, and
used-
now my computer won't start. It's like
First-
the delete system.
Yeah, neighbor once gave me a computer machine and I deleted it on DLL.
I saw this funny link from like a r/sysadmin where it's like different ways of shooting yourself in the foot. Here we go. No, that's not it. Yeah, various ways of shooting your foot off. Here we go. Okay, so Perl, you shoot yourself in the foot and then decide it was so much fun that you invent another 6 completely different ways to do it. Ruby, you shoot yourself in the foot and then have to justify it to all your friends who are still naively using Perl. Let's see, Java, you shoot yourself in the foot, but you have to wait for the bullet to hit you while it goes through collects all the exhaust gases and combustion byproducts and determines which to throw away. COBOL, allocate $500,000 to a project, find foot, bullet, gun, run, press trigger, go for copy rate, return in time to put foot under bullet. Mac OS X, you shoot yourself in the foot, or you try to shoot yourself in the foot from the GUI, but the gun has inexplicably turned into a bag of Skittles. Etsy, 100% alpaca wool gun cozy. iOS, you go to shoot yourself in the foot, but gun.app was pulled from the Apple Web App Store. Twitter, hey, I just shot myself in the foot. Can I get a retweet? Ow, or hashtag ow, hashtag it hurts. Google Plus, I can fire my gun all I want. It won't hit anyone. iPod, you shoot yourself in the foot, but you miss, and when you try to reload the gun, you find out that it only had 1 bullet, and you can't change it out, you have to buy a new gun instead. Security. Everyone has been indiscriminately firing their guns, so the front door resembles Swiss cheese. While you futilely attempt to impose trigger discipline and range rules, a hail of bullets comes through the holes from the outside from 10,000 other guns hitting you and everyone else in the room. It's
Could
still
be
your fault.
just different.
Or different sensor.
Yeah, it's like
Mailing list. You try to shoot yourself, you try to shoot your foot, but instead it seems to fly and hit the wrong sorts of people. Best Buy/DQI. You shoot yourself in the foot, but they say that's not enough, and you must buy bullets for your other foot, hand, leg, arms, and head, and wallet.
use HDMI or,
Yeah, HDMI.
okay.
Flash dot. I'm better at foot shooting because I have a 5-digit ID.
Wow.
Probably point blank.
Instagram. Here's a picture of my gun. It has a cool cinema effect, awesome Helvetic effect, and it's an HDR.
Oh, this is the end.
GitHub. We provide you with a CNC machine shop and a progressive reloading press for you to make your own gun and round to shoot yourself in the foot.
So this. Not this. That.
Here's one for anybody.
Too many options.
You have a meeting telling everyone how this gun can blow your foot off if you're not careful with it. You tell everyone not to point gun at foot and pull trigger. You build documents explaining never to point the gun at the foot for any reason.
Okay.
Even install foot recognition modules on the gun to disable firing like he does them in the presence of a foot. Come in the next morning, there's 10 tickets from users that have blown their foot off.
You can unplug my plug. I've got a good battery.
Then that's.
Yeah, the battery in this is pretty strong. I was in the data center a couple of days ago and was using this without being plugged in for at least an hour and a half. And it was still sure pretty cool. I almost never use it on the battery. Wheel.
Yeah. Desktop is messy.
Yes.
Looks like something you'd see on, what was it, that video, the website is down, where like the guy has a huge, crowded, what do you call it, has a desktop that's cluttered. I've seen some. Yeah, there was one, there's, at one point, sure. At one point, the guy remote desktops into some user's desktop, and it's arranged in the shape of a penis.
Someone with too much time on their hands.
Too much time and not enough imagination.
Have you seen the clip though? It's called like the website is down or something.
Thanks.
I'm too busy with my desktop.
Well, I mean, it's an old video. How to shoot yourself in the foot using Gentoo. Spend 2 weekends skimming the metallurgy process in the docs. Head to IRC and trick usuals into helping you. Quote, if only shooting yourself in the foot were as easy as it is in Windows, more people would use Gentoo. Take your favorite compact SMG and bring them all at the bullets from the instantaneous solution.de just to show you how wrong you are. Blow your entire foot off from the ankle down as efficiently as current ballistic physics will allow. EHP. You fire the gun, it misfires, shoots several other people in the foot and takes out your eye. At the rehab unit, you continue to insist that it's a perfectly fine handgun and you can shoot a lot of great things.
ARM has a really good processor name.
Grab some
That's
water.
really memorable. APM 883208.
I think they should have gone for hexadecimal.
Right. Silver bullet, you can tell just from the name.
It's IPv6. Talking about the names of the ARM processors. How easy they are.
Ben, what? Have you heard from Steve within the last few months?
I haven't heard from him in like forever.
Yeah. Or since he went into the rehab.
I don't know if he's still there. Which one? Do you know which one it was?
Well, he went to the one in Brookline,
Yeah.
which is actually across the street from his house.
Right. But I thought they.
He got kicked out of that
kicked him
one
out.
and went to another one. Blake Parker told me, but Blake has since passed away since, so I don't really know.
Rocky text. I don't hear from him anymore because he doesn't have a phone now.
Doesn't have a phone.
He doesn't have a phone now. I mean, what he used to do is he had a phone and he would like ring me twice and I'd call him back because it would cost him extra to call me direct. And he doesn't do that anymore. And when I dial the number, it says this number is temporarily out of service. Been like that for a few months.
Actually, he won his lawsuit.
He did,
Yeah.
but he was trying to, the lawyers were trying to contact him. And I asked him about it, not directly, but I sort of said, well, what's the deal with these lawyers? And he said, let him come to me. So, so even though he won, he's sort of like almost giving it up by default.
Do ARM processors have upgradable microcode?
Is there
What
a limitation
microprocessor
how long you have
nowadays
when you win,
doesn't?
when you win a case?
There might be a little bit more hierarchy loaded, but
That would be-
probably very, very minimal, and you're expecting to load microcode at one time. I can't actually say that for certain.
We may wait too long, and it will be,
Either that or he might have gotten the settlement and moved away.
on an island somewhere.
Probably somewhere down in Texas.
Well, last I heard, there's this other woman that he knows. She lives in Denver, and she said that his relatives were trying to contact him if he had moved back to. Well, this is Louisiana, I guess.
Okay.
Maybe that and Texas, but if he had moved back there, he probably would have contacted them. So they wouldn't be calling her to say where is he.
I know where he lives.
I think he's still in Brookline.
Yeah, I know where he lives.
Yeah.
Right on St. Paul Street, because I brought him a laptop one time.
Yeah. Oh, that's the one that got stolen,
What
because he was at the rehab for a couple of weeks, and his landlord did something. Let some people into his apartment, and then when he came out of rehab, he noticed that his computer was covered, but he didn't want to say anything to the landlord. So that thing is gone.
Okay, anytime you want to start.
We can start exactly on time.
We can start exactly on time today. Everybody okay with it?
Sure.
Okay, I'd like to introduce Federico Lucifredi. And everybody knows Federico. If you don't, he'll introduce himself.
Inevitable. So it's actually nice to be back here. I actually managed not to present in 2016, I realized, which broke my 8-year streak of presenting every year at BLU. Very disappointing. I presented in December 2015 last time, so it's close, but so maybe I need to present twice this year to make up or something. But Yeah, so for those of you that don't know me, I'm a product management director at Red Hat. I work on software-defined storage on Ceph, the Ceph project. Before that, I was a product manager at Canonical on the Ubuntu team, and I was the product manager for Ubuntu 14.04 LTS. And before that, I was known as the systems management czar for SUSE. So lots of distributions. No Gentoo, but we'll see. We'll see about that. So that's me in a nutshell. So why am I interested in building clusters? It's obviously not a professional requirement, but as a PM, I find it that I cannot do my job effectively unless I actually use my product, which will probably sound ridiculous to you, but there are lots of product managers who don't. So for Ubuntu, a big part of the user base was OpenStack. For Ceph, obviously, distributed system. And so now I'm looking at Docker, Swarm, and Kubernetes, other distributed systems. So to try things out, you need clusters. And since sometimes you can just use time on AWS or on DigitalOcean, my favorite, but a lot of these products are not necessarily cloud products. For example, Ceph is usually not used in clouds. It is used to build clouds. So from my point of view, part of the exercise is to see the product the way a user would see it. If I can call engineering and say, build me something crazy, and they do it, I can see the product in a way that's unique to me. That is meaningless. One of the things that you have to do as a PM is understand what people are using your product for and how. And if you create something that does not reflect the reality out there, then it basically is a waste of time. So that's where we get to building clusters. Besides that, it's fun. At least I find it fun. So that's how we get to it. On the other hand, being a personal activity, it's also budget constrained. It's not something that I can just assign Red Hat money to because I want to build a cluster. At least most of the time I can. And I think that having constraints like not spending too much money on it also makes it more interesting. If you have infinite resources, sometimes you lose sight of things in too many options. So I kind of lied because I said that I had 3 clusters. In reality, I have 4, and I'm going to focus mostly on 2. So the abstract wasn't quite accurate. But what are these clusters for? So one is so that I can run OpenStack configurations. Originally, it was because as Ubuntu PM, I had a lot of OpenStack users, and so I wanted to run OpenStack. In the newest revision, which is the one that we will look at, it's because Ceph is the storage system preferred for OpenStack. So I need an OpenStack cluster running so that I can consume Ceph and see what it looks like to that part of the user base. So that's one. Then there is Ceph again, is supported only on x86 right now, x86 64 by all vendors. Code base C++, it could run in a lot of places, and there are community builds for ARM, but nobody has gone out and said we'll support it for ARM yet. So I thought that it would be a cool idea to build a cluster and see how far I could get in terms of building a Ceph cluster on ARM using the tech preview of RHEL on ARM and the engineering builds that we have of Ceph on ARM. And so another excuse to build another cluster. Then I'm making plans for our Kubernetes and Docker support, and so a cluster for that. And then who doesn't have a Raspberry Pi cluster these days? I mean, come on. So that's 4 clusters. There is a lot of variety. There is a lot of difference in the amount of time I spent designing things. Like the OpenStack thing took an enormous amount of time, way more than anything else. The ARM thing is taking my time right now because I'm trying to actually get the software side worked out. I'm trying to produce some marketing out of it as well, so there is some kind of time pressure. The Raspberry Pi thing is because, as some of you that have seen me speak before know, I like small single board computers typically running ARM, so the cluster, the version there was inevitable. And now that there is a variant of the Broadcom chip that is ARM 64-bit, then it seems actually useful. Plus, there are some interesting extensions that you can throw in, so just too interesting to pass up. The Docker thing is the most straight build. I wanted it to be simple and not cost me as much time as OpenStack did, and to be production ready much sooner. So I kept it as simple as possible. I literally built a dish rack cluster, as Kurt is not here, but that's what he would call it. But then one of our vice presidents, I had plans to make this into something much fancier. It was built on a dish rack, and then later it would have its own custom case and whatnot. But then one of our vice presidents walks by my cubicle, and he actually feels that he must send me an email saying how cool the dish rack cluster is. So now it's forever a dish rack cluster. It's never changed. That is probably the most powerful one, and it is also a fairly straightforward x86 build. And it wasn't too expensive, which is kind of cool. They have different aims, like the ARM one will be a bit of benchmarking. The other ones are discovery in different ways. So tonight I just wanted to talk about hardware. Let's go into two of these into as much detail as we possibly can, and then we'll refer to the other ones who are interesting. So this is the first one. Let me find. We want to put pictures up so that I don't just point at something you cannot see. So now there are a number of.
Fan of Batman?
I'm sorry?
Fan of Batman, the Wayne Enterprises?
Oh, yes. I usually decorate my test rigs with some label from some sci-fi or some fiction that I like. So there is the Stark Enterprises test rig and the Wayne Industries, and another one has all sort of labels from Firefly and stuff like that. So yeah, it's just playing around a little bit. So this we nicknamed the Bat Cluster because of that, but really it's a fairly small cluster, but it was meant as a technology test for ARM. So these boards were some of the earliest ARM v8 implementations you could get. Applied Micro did their own silicon. It's not one of the Cortex designs from ARM. It's APM's own design. And the boards have been around for a while and used a lot in development environments, which is why I was able to ask a friend at APM to get me 3 boards. Now, what I have up here is the original Mustang. That's the code name for the board. The aim is to have a development environment for the X-Gene chip. That's what APM called it in reference to Marvel's mutant factor. So they also like to play with names. So the X-Gene 1 chip, which is hidden under that heat sink, is their ARM v8 implementation. It's an ARM v8 straight. It's not an A revision or anything like that. And it is their own. Now, in the V1, this had 8 cores between 1.5 and 1.3 and 1.5, I think. Oh no, I'm confusing. This one is 2.4 gigahertz. So 8 cores, 2.4 gigahertz, 64-bit ARM. Now, we know that ARM cores are a little bit wimpy when compared to x86 cores, but on the other hand, they are a lot less power hungry. Why are they interesting? Well, some people, the idea is that you're going to change the data center and go from x86 to ARM. Maybe it's the case. Not speaking for Red Hat, I personally think it's going to be difficult. Intel has, or x86 more properly, has the market well boxed in. If ARM manages to replace an x86 in the data center, it will only be because people are at Intel are asleep at the wheel. It's much more likely that AMD can subvert x86 economics with their new RISM chips than for everything to get re-architected around ARM. But that's fine, because ARM is hugely successful in IoT and phones, of course, and tablets and all mobile stuff. And who knows, I may be wrong. So I don't see it as interesting as a data center platform, but this is what this chip is meant for. On the other hand, what I see it as interesting is that Ceph, the storage system, is built around the storage daemon that we tend to run on x86 machines, and then talks to a certain number of drives. In certain configurations, 12 drives per machine. Other configurations, 60 drives per machine, depending on whether we're looking for high performance in IOPS or high performance in throughput, and we don't care about latency. That is a little bit arbitrary, and we spend a lot of time taking these decisions about what machine, with what processor, with how much RAM for this many drives, which is very useful to customers, but do we really need that? So the thing that could be interesting is hard drives can now get ARMv8 chips on their controller board. And they're getting powerful enough that we can run the Ceph OSD on the hard drive. So there have been a number of prototypes called Ceph drives that we like to show at conferences with different partners. And that is something that we consider interesting, that I consider interesting, in terms of where this could go for storage. So that's why I'm interested in Ceph on ARM, and that's where this cluster comes from. Now let's look at this board a little bit in terms of purely the board. Let's leave aside the cluster for a second. So it's a micro ITX board, if that acronym means something. I mean, people define form factors as they please these days, but that is the standard, the supposed standard that it has to meet. I have no idea why the fan is offset. I always thought it was cool, but not quite clear why. The idea from APM is that this should look as much like an x86 machine as possible. So initially they ship with U-boot, which is a bootloader that's very popular with embedded developers and that I personally love. In the second revision of the board, they replaced it with a UFI bootloader from American Megatrends. So it's progressively looking more and more like an x86, and Jon Masters, that has presented to this group before, is someone that actually is doing a lot of work to make ARM a data center capable platform. So a lot of credit for that kind of evolution goes to him. Now I have this version of the picture saying what's on the board. So as I said, 2.4 gigahertz, 8 cores up there, but ARMv8 cores, not Xeon cores. Power connection is standard. There are 4 SATA ports up there. And there is a PCI connector. There are a few headers for board bring up, which are interesting if you're an embedded developer. There is a serial port. This card has no video, so you bring it to life using that. Literally serial port in old format. There is an SD card drive, which is really handy, especially for this use case. You can boot from there. You can boot from flash that's built on the board, or you can boot from a SATA device, depending on how you configure it. There is, we need to see this from another angle. There are, there we go, 2 GigE ports, and there is an SPF for 10 gigabit Ethernet, which is usually unpopulated. You have to put in the transceiver. Obviously USB ports.
Where's that controller? The 10 dB controller that resides where, like in the chipset?
I would imagine it's in the chipset. And then there is another 1 gigabit Ethernet, which was meant as a management controller. This board doesn't have a BMC or any sort of management board, so the management designation doesn't mean anything.
So can you actually use that as a third gigabit?
Yeah. And for some of the developer kits, the oopsie. Which one here? For some of the developer kits of the SATA ports, only the first one was enabled, because initially there was arbitrary distinction between whether you paid $1,000 or $2,000 for the board, and there would be a different chip, and some things would be different. But the SATA port enablement was purely a BIOS setting, so you could just enable the other ones. It was an interesting quirk. You could just change it in U-boot. Another thing that's quirky and interesting is, let me see, where is it? Not that. Oh, I have it somewhere else. So we'll just scroll here. So this one is the B board, the one that started appearing 3 years ago, just about 3 years ago. And then there is the 3C board, which is the one that's current now. And if you look at the cluster, you will see that there are some things that are asymmetric, because this has 2 C boards up here and 1 B board that I had from before. And so differences, the C boards have 2 serial ports instead of 1. Handy for debugging, I guess. Another difference is that ports have moved around, some relocation of stuff. And the one that's most visible to me is the SATA ports have moved. So the SATA ports used to be up north and on the other side here, while the SATA ports now are towards the side of the board. But other than that, there isn't much difference. It just makes this more colorful with silver cabling coming out of weird places. I think that's more or less it for the board. As I said, the original versions came with U-boot. These versions come preloaded with UEFI. Personally, I hate UEFI because it just gets in my way. But you know, it's, I suppose, a necessary evil. And it makes the platform certainly more enterprise. You can run it with both. You can upgrade the old boards to UEFI if that's what you need, and that's kind of what I did here because I needed them all to look the same. RHEL wants to use UEFI, and I wanted to use RHEL for this cluster. As I was saying, I want to do some marketing, so I cannot use CentOS or Ubuntu on that. So a little bit of tweaking there, but nothing too substantial. APM gives you instructions on how to flash the BIOS and switch it to a new one. How does this work? So we learned about the board. There is some weirdness here in terms of power. So this is meant as a test bench for one AT format or baby AT format board. So a full-size board of the old standards, which is really nice. And if it's really heavy, actually it has a stand back here so it doesn't flip over, which I don't usually use. There are other extensions like fans and other things which we don't have now because they would get in the way of you looking at things. But other than that, it's pretty much a weirdly shaped case that has all the buttons and interfaces that a standard board would expect. You could have USB ports here and sound ports that I didn't bother to mount because we don't need. But then we had to adapt things because here we're building a cluster. So I found some standoffs on on Amazon that are exactly the height that I wanted between the boards, and so that's kind of the limit. I can take off the board and the bar and have more boards, but that's how I got to it. It ventilates very nicely, so no problem with heat or anything like that. There is no networking on this. I just go off to another router because there are only 3 nodes. No need to build in the network. But this was meant as a storage test cluster, and hence here the case. So there are 8. I guess I should explain the hardware, and then I will explain what is that I'm trying to do. So this is a Vantec SATA array, and it's a very simple box that they have bigger ones. This one has room for 12 drives in 2.5-inch form factor. It has a fan. It gives you SATA access to all of those boards, and it distributes power to all of those drives. So it's very dumb, very robust. It's made of metal and fairly cheap. Perfect. So my biggest fear was that this thing would actually try to be smart. Instead, it passes through the SATA ports, which is ideal for this. So there are 12 drives here. After I had my friend at APM get me these boards, I had my partner manager with Seagate ask them if they would loan us some drives because we wanted to do the test with flash, and I wasn't going to buy 12 flash drives out of my own pocket for this experiment. So we pulled some strings with a friend, and they loaned us 12 drives for a few months. These are 240 gigabyte drives. We didn't need capacity. What we wanted was SSD performance. These are Seagate XF 1230s. They are fine drives, but there isn't anything special about them other than we wanted enterprise type SSD performance for the test. So we're passing the drives through using all of that SATA cabling that we see. This is nice, so we don't have a mess of drives. Passing the drives to each board. So we have 4 SSD drives going to each board. As I said, we have 8 cores. So perfect. We have 4 cores for the operating system if it ever needed them, which hopefully is not the case. And we have 1 core each for each drive. Ceph runs a storage daemon called an OSD that manages the storage. So 1 instance of the OSD daemon will be running for each drive with a dedicated core. The board has 16 gigs of RAM, so we can assign 2 gigs of RAM to each OSD. It's a fairly comfy environment. And what is the test that I want to do? What I'm curious about is, can we, with an ARM core, saturate an SSD drive in this configuration? The odds are we can't. But it's an interesting experiment to see how close we can get, because this is obviously a lot less power than any x86 thing that we could do. If we can get close to saturating the SSD, then we're onto something. If we can't, well, then it's interesting to understand how far are we and how far ARM needs to go to be able to accomplish that. So that's the aim of this cluster and the whole aim of the experiment, besides me having fun with hardware. Of course, as I was saying, the drives are mapped to Ceph. So I'm not booting from the SSDs. I'm booting from the SD cards back here, which are perfectly fine for the operating system. The operating system is certainly not the bottleneck here. And as I said, there is flash on the board, so you can flash it as if it was an SBC and just boot from there. I would prefer to work from the SD card. So the other possibility is that you can boot from USB, so you could use USB sticks. And in fact, one thing that I noticed while building these clusters is you can never have enough USB sticks. You're always flashing something and booting from something different, so unless you want to be rebuilding your disks all the time, that's what you wind up doing. Now let me show you a few more details in terms of pictures. So these are pictures of the original board, the one from 3 years ago. I was posting This was the last blog that I wrote before I resigned from Canonical. So this is all Ubuntu based, oops. But, but it is a nice analysis of the board on its own that you can read if you're curious about it. Basically, it describes the hardware bringing up. We're just using a standard power supply, and I overthought the power supply, but whatever. And I was trying to keep the cost down, and we had this experiment where how cheap could we get SSDs, and I managed to find that there were a bunch of used Intel SSDs for $30 on eBay, and I built a different cluster using those, but that's what this originally booted from. Setup power, a few details on the processor that we already went over. The serial port, you get this cable that is serial, I don't even remember how many pins, I think it's 9. Yeah, it's 9. Traditional 9-pin serial, and it goes to USB, and then you have the USB drivers on the other side. I like to use Macs as consoles, so in that case you need to install drivers. For Linux, you don't. They are part of most desktop distributions, and you just connect screen to the TTY that's bound to that serial port. So that's how you get in, because as I said, there is no video card, so the boot sequence will unfold through that. We saw the details of the board, so let's see if we skipped anything. Interesting. Apparently these used to be USB 2. They're not anymore.
What are they?
They're the latest. Let me see.
Oh, USB 3?
Yeah. Let me see if I'm not over-promising, but I'm pretty sure. Yeah.
I think it said 2 USB 2 up above. Yep,
No,
USB
it's still 2 because it depends on the chip. So they upgraded it in, so the XGene 1 is the one that's here. There is an XGene 2, and now APM is sampling an XGene 3. So I guess they upgraded in the chip, so the board is staying behind. The XGene 3 actually is interesting. I cannot get my hands on that yet, but it is a 32-core ARM processor with effectively these cores. There are additional enhancements. It goes all the way to 3 gigahertz. They estimate that the performance is 6 times that of the predecessor. That probably is a marketing statement, but obviously it's a faster chip. And supports DDR4 ECC, so that also helps with performance. And the XGene 3 is an ARM v8A, not just a straight v8. So let's see. Where was I? Oh, we were looking at the blog. Never mind. So PCI, serial, now there are 2. Of course, the serials are coming from the chip, so probably there are 16 serials or 8 serials or a very large number of serials on the chip. Just a number of, it's just a question of how many are wired. The first version 1 is wired, and the second version 2 are wired. There is I2C support, which is not brought out here, not as far as I know. SD card support. I believe it goes up to 32 gigs. And there is a JTAG if you really want to geek out in terms of embedded debugging, like building your own U-boot or something like that. There is the SFP for fiber endpoint, whatnot. So the way you bring up Ubuntu or CentOS, frankly, the one that's preferred, not the one that's documented, is that you flash the OS straight to the drive that you want to boot from. And that's why this blog was fairly popular, because it would walk you through that rather than through the steps to install. Instead of running the installer, you would just flash the image in the right place and you would be done. And so you can see that I'm doing that with my laptop and just partitioning the thing and putting the image in place. And then you just connect with screen to the serial port and you're in. Well, there are a few details. You have to initialize the storage and details that we don't need to go in here now. But That's it. And this is U-boot based. It's not UEFI based steps, of course. And this is the little change in configuration that gives you the three additional SATA ports that I was describing. So in terms of making this a little bit more real and showing you what this looked like, okay, we looked at the board. This was my working setup. Probably first boot for the board. You've seen all this. I was using a Samsung drive for that. The kit arrives in this box, although there are 3 or 4 variations of the kit. This one was the cheapest because I purchased it, but there is this variant board only. There is another one that's ready for rack mounting. There I probably have a copy of, which was the second board here, and that I was sent for sampling. And the third one comes in a desktop case. So there are a number of variations on the theme. Flashing the drive. Let's see if there is anything else interesting here. I think that's it in terms of the historic version of the board. In terms of the build of the cluster, probably we have a few things more. So, right, this is the way the rack mount looks like. It's very neat, but nothing special. And this is the way the desktop version looks like. And I probably took this mostly because I wanted to remind myself the serial numbers. But so, because we wanted to fit everything into this, using one ATX power supply, as I did in the blog, wasn't good enough. So I found 3 Flex ATX, which incidentally is the same format that guy over there uses, and it's a fairly common format for data center power supplies. I got 3 of them and managed to fit them in less than the space of one standard desktop power supply, so it looks fairly cool. I had to flip one around because there was some problem with fan placement, and also the screws didn't quite fit, so this was better. But there is another thing that you need to know about building or jerry-rigging these things. You don't need to tap screws, not necessarily. I mean, you can if you like to do that sort of thing. But there is this 3M tape that once you use it, you will never remove it, ever. I mean, a few years ago there was coverage on the fact that Ford was now assembling F-150s using glues, that it was cheaper to glue together some certain pieces of aluminum than to weld them, and they had industrial glues that were basically, you're never taking these apart. Now this 3M tape is not in that scale because it would be dangerous, but I have a test case where I put a power supply and I used this because I was in a hurry. I bent a screwdriver trying to take it off. You can't remove that if you use enough of it. So, assuming that you're not planning to remove things, and I have a funny story about that later.
How big of a screwdriver was it? Was it a thin screwdriver?
No, it was
or a thick one?
It was a real screwdriver. I damaged the test case. I bent the screwdriver, and eventually when I went full Hulk on it, I split the power supply in the middle because it was the weakest thing. So that thing is really impressive, and it's great for when you can't drill on things. So here, the 3 Flex ATX things are together forever, and actually it works like a charm. So highly endorsed for a lot of these things, and I think I'm going to use that on this for one problem that I discovered recently that I'm going to go into later. So, okay, here is the difference of the serial ports and port placement that I was going over before, and you can see that there is one board missing because one of the boards turned out not to be live, so we had to replace it. And yeah, here is the detail of how the power supplies are stacked. Despite the gluing, I wanted some screws in, which is why the third one is flipped, so that I would get 2 screws to fit the old holes. These are the specs of the power supplies. They are standard Flex ATX, but these were also selected because I wanted them to be supremely cheap. So the standard was, if they can sell on Amazon without getting kicked off Amazon, this is the power supply that we're going to use, and it was a good standard. And yeah, you can see that the 3M tape is at work there. This is a smaller version of the same case that I use for things like Beagle Bones and Raspberry Pis. It has the same design of this, which is it's a Lian Li. I think it's a PC 105. But if you look at Lian Li on eBay test bench, you find these, and they're absolutely great. The ones that are hard to find are the small ones because they've made them only for a very short time. And because I like using test benches so the boards don't move around. And if you have ever done embedded development, you know that 9 times out of 10 you ruin the board because it's moving around your desk. So if I'm working on an open board, I want it on a test bench. And so I wanted something for the small ones to just make the Raspberry Pis and other things look pretty. These ones are extremely hard to find. There are some that are in Ferrari red that look spectacular, but black is fine if you can get it. And I'm designing a power board that will fit in the hole so that we can bring out, you know, for the SBCs, it's not AT power all the time. So you need to have power options. And you have to have USB power and a few other things. So I'll fit that in the hole and then mount other things up here. But yeah, these, there are fancy test benches which are built for either the Bitcoin crowd or people that want to build good-looking hacked computers. But the Lian Li ones are usually, you can find them for less than $100 and they're excellent. And they've been around for years, so there are a lot of them. Not of this small one, but of the large one.
Yeah, cheapest one on Amazon right now is $109.99.
Yeah, that sounds right. It will go between 99 and a few bucks over 100. So this is the hard drives when they arrived, and it's actually pretty cool that the Seagate knew that we needed 12 drives, so they sent us 13 because one of them could fail. That's the right thinking. This is pretty much how we finished the hardware assembly. I don't think that there is anything else here. And yeah, here is how it looks when it's powered. So blue lights on one side, and let me see, maybe I have the board has actually pretty nice LEDs itself. So there is a lot of blinking lights going on.
I'm tempted to start going on a rampage. Every time I see yet another bright blue LED on something that doesn't,
but specifically for
with
blue.
a very, very, very dim red LED would work fine. It's just the blue is fine.
I don't like red because, but I agree. The bright blue ones are very annoying.
Yes.
These ones are not super bright, but I have a device in my house that there is where we sleep, and if we forget to put it to sleep, it's like laser in your eye.
Yes.
How strong it looks when your pupils are fully dilated in your sleep. So I can relate, but it looks cool. So I don't have a picture here. You can probably find one on my Twitter, but there are a bunch of LEDs for debugging on the board itself. The old model there in front, and the new model there for, somewhat here on the back. So there are lots of LEDs flashing when this thing is going, which is kind of cool in an old-fashioned way. All right, so we already looked at the board differences, and this is how I had the boot sequence for U-boot in the blog, if you're curious. But this is how the boot sequence looks like for EFI when you have the newer version of the board. So let me see. Maybe no. This is the bits themselves, and then you get to the UEFI shell and the installer itself. And this looks exactly the same for both CentOS and RHEL. The UEFI shell is actually abominable. It's like typing in DOS, an even uglier DOS than DOS. But all that you have to do is type a couple of commands to set what the boot device is and to start the bootloader when you're setting up things. So that's fine. In this case, there are a ton of devices because, as I told you, there is the flash, there is a USB stick that I booted from, there is the SD card, and there are 4 SATA drives. So this is one of the most storage-rich environments ever for this type of board. Okay, so I think that's it for this particular cluster. And if there are any questions, this is the time. Otherwise, we'll switch to the other cluster. And I'll check my notes to see if I forgot to tell you anything.
So how you do the networking?
Right, because there aren't so many ports, I just take the management port because it's the one that comes up first, and I bring those 3 ports out to our lab network. I don't do anything special.
Do you have a front network and back network?
That's a good question. One should have a front network and back network with Ceph or with OpenStack, but this is too small of a cluster. There is also another thing, which is that Ceph requires a certain number of OSD daemons. Generally, we say 3 hosts of OSD daemons, so there will be 12 OSDs here on 3 separate hosts, so it's a fairly minimum configuration, but it's a valid one. However, there is the Paxos daemon, the one that keeps quorum of the cluster, the monitor, that is supposed to be running on other hosts. And it would be kind of pointless to have 3 more of these boards just to run the monitor. In a healthy cluster, it's not doing anything. So either I'm going to co-locate it here, which is most likely what I'll do. I have extra cores on the board. I can assign one to the monitor.
With that many Ethernet ports on them, you could simply use the extra Ethernet
Oh yeah,
ports
you can
for the
totally
back
do it.
network.
But because this is going to be entirely a storage test, I'm not segregating the networks the way I would, the way I do on the OpenStack side. So yeah, if you were building something that looks like a cloud, you'd have a front network for users.
Well, I'm saying you've got 2 spare ports on each of them. You can simply wire them in their own little back ring between the boards. And
oh, I see what you mean. You could do, yeah, but that would be kind of cheating. You have, for this to be somewhat realistic, you have to go through the switch and have that in the picture. It shouldn't change things much, but it's more realistic to do it with the switch. The other thing that you could do is that you could, since you have the 3 ports, you could have the front network for the users, the back network for the data replication, which should be private, and then the third network would be reserved for management activities, so that if something goes wrong, nothing that's happening on the other networks can prevent the administrator from getting in and fixing the problem. That would be the best practice. Here it's just a storage test, so we're not splitting those off. But we are doing that in OpenStack, so you'll see that the networking configuration for the OpenStack cluster is a nightmare. Okay, anything else here? Let's see.
My other question with the networking, you said that part of the test that you wanted to do with this was whether you could saturate a disk.
Yes.
Wouldn't the network be the bottleneck?
I don't think that we'll get there. I think that
oh, because you're targeting one disk.
Yeah.
You want to saturate just one.
No, I want to saturate. I would be fine saturating one disk, but because I have dedicated CPU for disk, saturating one disk or saturating 4 disks would look the same thing if the load generation is local. If load generation is external, as it will be, you're right. We could run out of network, but I think we can be clever in terms of asking for very large blocks, or we could populate the 10 gig interface and use that. In a production Ceph cluster, actually, our recommendation would be minimum to have 10 gig. But I frankly don't think that, I think that we'll hit the CPU way sooner than we hit anything else. And then we'll see what else we find out and what else do we want to play with at that point. The other thing that I wanted to point out is that while you see that there are a lot of power connections for SATA back here, because SATA power is decoupled from the storage connection on it, a nice thing of the cage is that you can bring power to the drive cage with a single cable, which is what this fancy Red Hat Red power cable is doing.
Did it have orange cables before?
Well, the other cluster actually said Ubuntu up here. This one says Wayne Enterprises. It's way cooler. But yeah, I think that's about it for this one. The other one has
Question?
Sure.
So Ceph is not running yet, as you said, because Ceph for ARM is not yet ready.
So Ceph, there are people that build clusters with this configuration, so it is possible. It is possible to use community bits to build Ceph on ARM on this board or on other boards. What is not ready is that there is no enterprise support for it. So if a customer wanted to get, like they get RHEL with support from Red Hat, they wanted to get Ceph with support from us on ARM, we're not ready to do that yet. And frankly, nobody else is. Nobody that's supporting Ceph today is supporting it on ARM. We're all doing proofs of concept and dancing around the issue because there is work to be done. Frankly, the code is fine, but it needs to be hardened. So we need to find what bugs emerge because of the change of architecture. Okay, so right now the state where we are as Red Hat is that we have internal engineering builds to do debugging. And the community has upstream builds that are even newer than ours, pretty much for the same purpose, so that the regression test suites can run against ARM, not just x86, and we can see bugs there as well. Okay, any other questions? So we'll see how this turns out, and hopefully if it turns out fast enough, you'll be able to read the blog with me explaining what's going on. And if not, I'll come back and provide you with the data privately here, or semi-privately. Okay, so let's look at oh, there were a couple of things up here. Now this is the official documentation of the board. We already covered everything. And there is this very nice chart on Wikipedia with comparison of all ARM v8 silicon. So this is actually quite cool. Saves you so much Googling. And these are the applied micro ones. The 3 is the one that I was telling you they're sampling right now. And I guess I could go and update and say that that is ARM v8A, while the Xgene, which is now called Xgene 1, is ARM v8 without the A. I don't know about the 2. I'm missing that one. So let's go to OpenStack. Now when we did the OpenStack from scratch talk a few years ago, I had the first version of this cluster, which was this on my desk back then. And it was 8 nodes, which later became 12 and overflew my desk. And as you can see, I had started with 1204, then it became 1404. These are these HP microservers. For the longest time, they've looked like this. Now they look completely different. They're about the same size, but they have a front that is painted in silver gray. And I think some people refer to them by generation. I think current generation is 8 or 9. I like to refer to them by model number. This is an N40. They call it N40L. HP just calls this the HP microserver. There is only one at any given time. This is an N40L of the HP microserver. There is a slightly older one, N36L, that has a minor variation in terms of what AMD chip is in it. And then the following one, which I think is N50 something, is the one that's all silver. But you can also call them by generation. And the silver one has 2 generations. Now there is a newer generation. When you're buying the current generation, it's maybe $600–700. But when you're buying the old generation, the prices plummet, and HP tends to have a lot of stock, especially old HP, because supply chain management, who knows what that is. So When they went from N36 to N40, there were a lot of these on the market, and when they went from 40 to the new, different looking one, there were a ton because it was obvious then that this was the old thing. So instead of being radically expensive, you could get those on eBay for, at the height of the sell-off, for like $150. And if you weren't too good, you would pay $400. So on average, I would say that each node would cost $200 to $150. But while you can get a reasonable desktop for that price, the cool thing is that these are actually servers. You have IPMI in them. They are designed by HP's server team. And it shows. Maybe they're not so good at supply, or were not so good at supply chain management, but they certainly know how to design hardware. So instead of buying a server for $2,000 or $3,000 stripped down to the bones, you have a server that has all the bells and whistles and an Athlon CPU, so not much muscle, which for building a simulation of a cloud that resembles the real thing as much as possible seemed perfect. So I started buying these, and they needed a bunch of upgrades, but initially this is how they looked like. That was the version, what now I call version 1 of that. When I told my boss at the time that I was building a cluster, he insisted in showing me what he had in his garage. These are various evolutions of the thing, which, well, let's go back to the aim. The aim of this design was to build an OpenStack cluster that could be rebuilt using Upstream community every 6 months with the latest bits. And it had to look like a public cloud, because that's what 3 or 4 years ago OpenStack was aiming for. So it had to have sophisticated networking, proper storage, proper management, and all that. So post-its to track what I've configured and what I haven't configured so far. There are 2 reference architectures for OpenStack Upstream. Of course, the vendors, Red Hat, Canonical, primarily right now, have reference architectures for that, lots of them. But Upstream has primarily 2 reference architectures in the deployment guide, one contributed by Ubuntu, another one contributed by Red Hat. The one contributed by Ubuntu is fairly simple, so this cluster was built around that. And actually, the guide, the version 1 of the guide was written, co-authored by Jonathan Prolks, that works here in the computer science department at MIT. I think he's part of the IT team. So he had a say in how that reference architecture came about. But whatever, lots of hardware setup, and that's what the various iterations of that looked like. Now, let's look inside for 1 second here. So as I said, they have nice details. There is a key to open it. There are a bunch of USB ports here, which for a server, not so useful. Also, if you're using Ubuntu server does not mount USB automatically, at least not in 1604. So that requires some setup if you're planning to do that, but not so relevant. There is space for 4 SATA 3 drives. HP ships it with 1. Then there is the motherboard down there. It comes with a kit of screws that match the drive sleds, and a few non-tools, I guess, or an Allen key, so that you can assemble this without going and getting a screwdriver. And these are labeled as not hot plug, because I believe that there is a bug if you try to hot plug these in some configuration. But in many configurations, actually, you can hot plug them, and it's fine. And in fact, if you have an N36 instead of an N40, the labels that say non-hot plug are not there, because it's almost hot plug. It's just that there, if you're unlucky, it's not. The networking side is also interesting, but we'll go into that in a second. There is another thing here. So why all those post-its? Because we need to get in drives. Also, we need to get in the drive configurations. This is supposed to be enterprise, so RAID, and it gets fun. But let's wait for that for a second. So there is room for a CD drive that, if this is an SMB server, probably you use, especially if you are in the first decade of this century. But now almost no one puts a CD drive here because you can load software using a USB key or an external CD. So this is space for a fifth drive. At that time, those were designed for the Ubuntu reference architecture, which uses RAID paired in 2x2 for it's been too long. For the compute nodes, so the Nova nodes in OpenStack, it would use RAID mirroring 2 drives and 2 drives, just mirroring each other. For storage, I believe it used to be that it would be one of the hybrid modes. It would be RAID 10 over the 4 drives, so that you had, can't remember if it's a stripe of mirrors or a mirror of stripes. I can never say that correctly, but
it would be stripe of mirrors, because if you do it the opposite direction, losing
invalidates
the
the whole
drives kills everything.
But I just cannot remember it in words, which is the right order. So in any case, it's RAID 10 for the storage ones, so that you have some additional performance from the spindles, but you still have security from data loss. That was the storage configuration there. Now for the 4th revision of the cluster, I have something more than I want to do, because I want the storage to be Ceph, obviously. And so these 4 drives will be OSDs, which means I need a 5th drive up here to be the operating system. And so I went on Newegg and I ordered a bunch of sleds and a bunch of cheap drives. Everything looked perfect until I realized that HP actually customized this, and there were some special rails that you would put to insert the CD drive in place seamlessly and without tools. Very nice, but now it's been 10 years. Well, no, it's been 5 years, and you cannot find those rails ever. So again, the tape comes to the rescue, because once the drives are in there, we're never going to take them out, so who cares? And I don't want to spend my time tapping screw holes here. Besides, it doesn't seem a nice thing to do. So, so that's how it's going to work for the new configuration. Let's finish looking at what the old configuration looked like, so we can jump into pictures of the new crazy configuration. So once that boots, I had this hanging monitor there to log in. These actually have VGA ports, so it's a much more normal experience. It's not like an embedded developers. And nothing, you set up your operating system like you would anywhere else. So the big effort is the fact that you're building OpenStack and that you need to design for that, which, if you've done it, you know. If you've done it, you know. But, so why do something once when you can do it 4 times? So since I built it the first time, OpenStack has released, I think, 7 releases. And I don't have the time to upgrade OpenStack 7 times. But I had the time to redesign the cluster 4 times. So this is the 4th version of the cluster that I'm preparing for the next release of OpenStack. And it's too big to fit on my desk. Besides, my new desk at Red Hat is not configured the right way to have a pile of computers like that. So first point is that we build furniture. So I built this shelf that now is around the back of my cubicle that is on casters, as you can see. And if you follow Adam Savage, the Mythbuster, he loves to build things using wood stapling guns, which really make it super fast to build things, and then you hide the staples. But the staples are flexible, so if you build something that's empty like this, doesn't have cross beams, the thing will flex. So hence the screws. Those are really long screws that I pre-drilled in, so that gives some rigidity. So this was Christmas project a few months ago. I went to the garage for one afternoon and I built this thing. And then I speckled it to cover the staples, and it looks fairly good. And that's how it looks vis-a-vis the servers. So it's structured so that there are 2 rows of 6 servers. And I had pre-qualified the nodes with the new configuration, so we can start building it. But first thing first. So the reference architecture that we want to build has power, PDU control for every power socket, because they were saying it's not enough if the thing fails to just have IPMI, we want to actually be able to pull power. So I found an APC power strip for, so last time I did the cost budget of this. So the PDU this time was $99. The design of the rack was made so that this would fit by length exactly. So it's not visible unless you look under the floor. It looks actually very, very stylish in the office, I must say. And this is switched, so you can connect to it serially or over the network, and you can say pull the power from socket 9 and just boom, it goes away. You have a few more sophisticated options, like you can define power cycles, you can bounce them. Too electrical for me, I just need to be able to reset it, says the reference architecture, and I can now. Interesting from the point of view of the PM experience is how much of a pain to set up these things is, because you have to update the firmware. This was old from eBay, so it had a 2002 firmware. DNS resolution didn't work because even something in DNS seems to have changed since then. I don't know if it's the Adam Kaminsky exploit or something, but they patched the firmware. The old firmware doesn't like the world anymore. So you have to figure out how to get the firmware in there using a serial port. So you start feeling the pain of the poor guys that do the data center stuff. But once you've gone through that, it looks great. And you see, you don't see it at all. It's there, and it's powering 12 servers. It has 16 power ports, which is an important element because we need more than 16. And you'll see how I resolved that. So, very nice. Form and function. And see, it runs right to the end, perfect in size too. So it tells you how many amps the rack is consuming, and you have a few controls, like you can reset the controller manually. There is a pin where you can press it and it will reset the password. So you go back and log in as APC if you bought one on eBay after pressing that pin. Or if you have access to the data center, you can own all of their power strips. But you know, if you have physical access, you own it. That's the rule. So that this is not a security issue. Some cable trays, just to look properly serious. And that's how the fully assembled thing looks like. There is actually someone that's an old friend at Red Hat that I've known from a long time, when we were competitors. And he has a passion for woodworking. So when he saw me building this, he was like, I never thought of doing this in the office. This is taking it to the next level. And
Was that Bill?
no, it was Daniel. But actually, we did have to take it to the next level in the office, because it turns out that the Red Hat office in Westford has very powerful AC. The air is super dry. And so my Christmas project started warping. So for a couple of weeks, we had it drying in the office looking like this and getting some attention from the executives. What the hell are these crazies doing? But it just worked fine. We just clamped the hell out of it and let it dry in that format and spackled a few cracks, and off it went. Facilities was nice about it. I was expecting crazy complaints, but no, nothing happened. So we're done with this part, but who says that you can stop at building furniture when you can also replace the firmware? So that's the next thing.
Wait, the cabinet had firmware?
No, the server did. So let me see if I can jump to. All right, so the power strip here is when it starts, it looks like this. The interesting bit is how many amps do you think the rack pulls, because it's in my cubicle. I cannot pull data center power in my cubicle. So that was also a design consideration. And it's also why the fact that they're not atoms, they are AMD Turians, but same story. I have 12 servers there, plus all the switching, plus the PVU, and it's all under 2 amps, which makes it cubicle compatible.
Amps.
2 amps.
So the nodes don't have any hard drives?
The nodes have 5 hard drives on the top rack and 4 hard drives on the bottom racks.
So you have 54 hard drives?
I have, let's see, 4 times 6, 20, 4, plus 24, 48, plus 5, 54, 53.
Everything was under 2 amps?
Yeah, but the drives don't need to be all running at the same time. You have to remember that because you're bound by the CPU, again, it must be a common thing of my designs, but because my point is that I want to run the technology, not have tons of users. I can run OpenStack with 2 Turian cores. That's not a problem. If I had users consuming that OpenStack, that would be a problem. So, question?
Okay, so the 2 amps is not including all hard drives operating at the same time.
Yeah, if we do a stress test, that's going to increase. And actually, that's a cool idea. I'll take note of it.
Yeah, since as it is pointing out, that's...
Flames is pretty, as far as I know, it's not a small number, with that. I don't know.
I think when I presented this server the first time, we also had power metrics, but I don't remember them. It is very conservative about power. The biggest draw are the hard drives, that's for sure. So, firmware. So this is what you do when you have too much time on your hands. You discover that there is the Russian BIOS for this server. This was before things went so crazy with Russia that you would never use any software coming out of them. But someone that happens to be Russian and has a very long name, so we refer to this as the Russian BIOS, modified the HP BIOS for the HP firmware for this machine. Specifically not the core BIOS, but the RAID controller. So we said this machine is a real data center machine. It has a RAID controller. It is made by, I think again, AMD, if I remember correctly, chipset-wise. You can download firmware updates. And this guy went in and modified some bits and repackaged the firmware so that we could access some chipset options that AMD has put in the chip, but that HP did not want to expose in the cheapest server on their line. So that we started with just, I think, basically the original shipping server just had RAID mirroring and RAID striping, and that was it. And I wanted the hybrid stripe of mirrors, mirror of stripe options, which I could not access even though the chipset would do it. So the Russian BIOS gave me access to that. There is another thing which is handy now that I'm building these into a Ceph cluster, which is that there is a JBOD mode, which basically is saying the drives are all on their own. There is no RAID going on, but the RAID controller is still active. And we like that for Ceph for one reason. RAID controllers tend to be battery backed, so that if there is a power outage, the last few writes still get written to disk, or they get written on resume because there is a capacitor that has a few hours of life there. For supported configurations, we consider that mandatory. We think that it's crazy to run with the possibility of losing those. So while Ceph never RAIDs anything, Ceph always uses drives straight. The replication is across nodes in the cluster, not across drives in the same node. Having RAID controllers is really cool, and so the Russian BIOS gives me the ability to do that and not default to the SATA controller itself. So once you have that, you can access a few more options, whatnot. This picture we made because we wanted to send it to the security team to make them freak out. Okay, so now we can go back to the details of of the actual build. So the cost will do last, and it's an update from the previous one. So this is pretty much the same story. We're trying to figure out what remote power, so what PDU socket is this driver in? Is there IPMI? So the second cost is, if we look at the drives, if we look at the nodes on their own, so there are 12 of the microservers. And we're going to say that there are 250 each on average when these were procured on eBay. But there is another $100 of RAM, and there is about, on average, because these were also on eBay, $75 of the IPMI card, which is the only option that HP sold separately. Servers have everything except the IPMI card. And because they made a lot of servers, but they didn't make a lot of IPMI cards, those remained expensive. So the server was about $400, $425 on average before the drives. Adding drives brought it over 500. But that happened over the years, so it wasn't so painful. And then, right, you see this one has RAID 1 with 2 drives. So this one was meant as a compute node. This one was the old version, the Mark II version of the cluster, where the Nova nodes had only 2 drives. Now the Nova nodes have 4 drives, so that they have some more resistance. Setting the stuff in the BIOS to configure the drives, nothing too strange there. Yeah, go on.
What do you mention about IPMI?
I only mentioned that IPMI is not part of the server itself. You have to buy it as an option. That's what I was.
Is it PCI card? Or?
Yeah, there is a slot that's dedicated. I don't know if I have a picture of the motherboard, but there are 2 PCI slots on the board. There is one that you must use for the PCI card if you install it. It has to be that one. So yeah, here is an example of the storage nodes, 500 gigs on each thing, and these will all be assigned to Ceph in the Mark IV configuration. And we would boot from a 5th drive installed in the CD case, in the CD spot. So lots of drives from Micro Center. This was the first version of this, the first pass at it. So then networking. Now we want to do, we're saying that here we don't pretend that we are in the real world, but there we're trying to build a micro cloud. So on that one, we really want to have networking separated. And we have, I keep losing it. We have the networking look like this. So we have, let's say that this is a node and this is another node. There are 3 networks. Each node has access to all 3. And one is private, and it's the data backplane. So any private traffic the OpenStack services have is going there. Ceph replication across the nodes is going there. That is not supposed to be routable to the internet. It's physically not supposed to be accessible. Then there is the public, which is where the customer traffic is on. So if a user of a Nova VM is coming here, they will be coming through that network. And then there is the management network, because in the reference architecture, the idea is something bad happens in your cloud, you have an outage, you still need to be able to manage the nodes to fix it. So if you were relying on the private network to do that, in some cases you would not be able to access the machines remote. Especially if it's your storage or some of the private services that are going crazy, or if someone managed to attack that. So the reference architecture best practice is to separate the management out. And we have the APMI cards, so we totally can do that. We have a dedicated management network. So this is how 2 of the interfaces look like. There is a built-in 1 gigabit interface, These servers unfortunately don't have 10 gig. You can only go so far spending a few $100s. But the built-in one is 1 gig, which was very respectable for its time. Let me turn that around. And it's up here over a few additional USB things. There is external SATA, by the way. Not sure what I will do with it, but it's there. The Flex ATX power supply is hiding behind here, and there are 2 PCI slots. The APMI card sits here. It has a new VGA port. It disables the old VGA port when you install it, and I like to remind myself of that so that I don't go there, and so I sticker it with an off to remind myself that that doesn't work anymore. That's the original VGA, that's the new VGA. And then there is the IPMI port and the management interface. Then there is an additional network card because we needed 3 networks. That one is also 1 gigabit, and this one also came from eBay, and it was $13 for an additional NIC. This is a special case, the head node. So in the old configuration, it's interesting, I forgot to bring a picture of that. But I have the drawing from that session. It's not clear enough. So, let me see. Yeah. In the original Mark I configuration that was desk-bound, these 3 networks would go, well, let's show you, it's complicated. The part that I want to cover is you're running OpenStack here. You're running multiple networks. You're responsible for those networks, for their infrastructure, so to speak. DNS, DHCP, all services you're running. Now, regardless of how you're running them, in that case I was running MAS. In this case, I'm not. But these are broadcast protocols, and they are taking over DNS for the subnet. If you're doing that in the office and you're leaking DNS answers, especially DHCP answers to the network, the administrator will come with a very big stick to you in times that you wouldn't believe possible. It's going to be a matter of minutes before they find you. So the first design was based on using a D-Link managed switch that had the option of filtering out DHCP traffic. So I could just tell the switch, DHCP traffic is not going out to these ports, and those ports would be the uplink to the outside world. So I didn't have to run a gateway server, I just had to configure a switch correctly, and it was my filter for not getting my shotgun-toting system administrator to visit me. Literally shotgun-toting at that time. So that was the design I did then. Now it turned out not to be enough, so I bought into the thing that we have to have a gateway. So we do have a gateway now, which is this. It doesn't have an IPMI card because it doesn't need to be managed. It's kind of part of the infrastructure like the PDU. And it has too many network ports, and it has 6 network ports. We just needed 4. So all the networks route into this, and I switch in software whether I want that network to be connected to the rest of the world or not. Right now I'm doing install, so I'm letting things fairly loose. When I finish building, I'm going to make the private network non-routable so that it can't go out there. But right now it's very nice. They have DNS, DHCP, all the trinkets, and it's actually fairly cool because I was debugging DHCP, which is not an experience I would wish on my worst enemy. And so I found all utilities to sniff. DHCP is a broadcast protocol. You don't need to do physical sniffing. You just get on the wire and say, tell me what's going on with DHCP on the network, and there are utilities that say, this is the stuff that's going on. There are bugs on the utilities that don't take regex correctly and don't filter things correctly, but once you figure out what the bugs are, you can see the exchanges. And I was trying to bring up the PDU on the network, And I could see the PDU saying, hey, I'm here, give me an IP address. And then the server saying, hey, you, here is your IP address, and then silence. And after trying a few things, I figured out that the problem was with the PDU, not with my DHCP server, which was the obvious assumption. I just built a new DHCP server. But the funny thing about this picture is that in frustration, I tweeted it, going, trying to sound clever. And someone that runs a system administrator site retweeted it. So this was the most popular tweet on my feed for a couple of months. It had like 30,000 views. And people started making all sorts of comments about what to do with the HCP. So I actually went back to marketing and I said, here, this is what you do when you want to get some attention. And they were like, I don't get it. I was like, I don't get it either, but it works. So that's the full story of the network? No, it's not. There is here the old network versus the new network. So the old network was segmented because that's what we, or rather someone, used to think at Canonical was the right way to set up a network for that kind of thing, that there would be north-south switches. And so the north-south switches were reproduced by using small 4-port switches, and the different rows of my cluster were on different switches, and then there were connections between them. That turned out to be too much of a pain. And really, yes, it was more realistic for simulating a big data center, but it wasn't worth the effort. So I replaced it with this. First of all, I made everything gigabit, and some of these came from eBay, and they were not a jumbo frame compatible. So we used those for IPMI, where there is no problem. For the other ones, we actually got jumbo frame support, which is interesting because Netgear doesn't rev the product names, but if you look at the small print and the actual version numbers, you can tell which ones do what. So I remember when I said that we had 16 power sockets in this APC thing. Of course, when you're building furniture, then you decide that you must build very nice cabling and do it as performance art. So I didn't want to cut cables, so I got them on the right length on eBay by saying these are the appropriate lengths. Did a very nice cabling job and got some weird looks as if I was crazy. But that was not enough, because now there are going to be 3 times 12, 36 network connections, and this is going to become a real mess. So there are 48 cables. We took care of 12. We want to make it neat enough that this is actually still something that looks good in the office. So that is me splicing 36 network cables. And that's how we got to, let's see, this is a storage story for later. We get to, this is the IPMI network, which is all yellow, and it's on the first switch. The second switch is the data network, the private one, and the third switch is the public network. And of course, we color-coded them because we want it to be nice. So white is the private network, and purple is the one that I was splicing when I was taking these pictures. So we have white, purple, and yellow. And I don't know if I downloaded a picture of the latest, but then we added lights. So it looks very, at night when the office is shut off, it has a very strong red hat hue on the back. That's when you start thinking too much about things. But, so that's how the full cabling looks like. And it's still pretty clean, so that people don't complain, and it actually looks nice. But it took a crazy amount of time because I spliced every single cable myself, and I lost my touch becoming a manager, so this takes me forever. But so far I haven't found a defective one yet, so apparently I haven't completely lost my touch. So that's the networking part. There is still a problem, which is that the PDU doesn't like the network too much, but serial, you can see here, that's the head node, the one with the 6 network interfaces. All the networks route through there, so you can see the different colors. There is a black network, which is the uplink to the rest of Red Hat, or to the Red Hat lab proper. And we needed a serial port so that we could drive debugging of the PDU. So we added a serial port in the other slot there and gave up one network port. Instead of 6, we have 5. Still fine, we just need 4. So that's the end of the story for the network. So now we go, oh, this is me adding the serial port to that node. So that changed. This is how the boards look like. There are 8 gigs of ECC RAM. This is not standard. I think HP ships it with 4, so that's why the $100 here. The APMI card would normally be where the serial port is, and the quad Ethernet is where usually I have only one Ethernet for the standard nodes. That's how it looks like in the office. Well, actually it has 2 monitors on now, so it looks even nicer. Yeah, it looks kind of like that. Now, the other side of the thing, storage. We talked about network, we talked about firmware, cabinet builds, wiring, custom furniture, and custom firmware. What else? So, there is a storage. Oh no, we didn't finish the network apparently. So I was telling you there are 16 ports on the PDU. We are taking 12 for the nodes. Where we don't have enough ports. We need 2 for the monitors, and those are non-negotiable. And then we don't have enough to run a whole lot of switches. So I didn't want to modify the power for the switches, but for the monitors. But I was happy to modify the power for the switches. So I sized a special power supply that has enough amps and has the right voltage and just goes to all 3. And then I used the crazy tape to make the wiring permanent. This was supposed to be the part that never fails, hence the tape. And obviously it failed. So Murphy strikes again. So the idea was, have I ever seen a switch fail? No, not ever. I'm not a data center guy. I suppose if I was, I would. But in my limited experience with a couple hundred computers, I have never broken a switch or seen one fail. I was like, no problem, the switches are not going to fail. So I taped them together, and obviously the one in the middle fails. And it doesn't fail in a normal way. It fails in a weird way where the first 8 ports work and the second 8 ports don't. So it even took me a while to figure out what the heck was going on.
Actually, that right type of switch, that's not exactly abnormal. All it means is it might be one piece of silicon handles 8 ports, and then you have a second piece of silicon for the
That totally makes sense, but I had never seen a switch failure before, so I wasn't thinking, oh, one port could fail separately from the others, so it took me a while to.
On the other hand, I have seen a Cisco network card that was DOA new, so.
DOA new I've seen for a lot of things. Also, cards, I don't know. Switches, no. So anyway, I did this fancy wiring, and then we wind up with one power supply. These cables, by the way, are again very easy to find on eBay, because on eBay there is an enormous market for security cameras out of China. So these switches use the standard, I can't remember what it is, 2.1 millimeters, the sockets that Arduino and everybody else uses, the large 1-pin sockets. So it's easy to find elbow adapters, Y cables, 3-way cables, 4-way cables, 5-way cables, all of them pre-made. So I just got all of this, and then I found a power supply with the right number of amps, and that was fine. So if I'm responsible for the failure of the switch, it's because it's too hot in that stack. That could be. I don't know. I have replaced it with one in the same, and it's working just fine. So I don't know if it was heat or what it was. Because I bought them used, it could also be that it was bad to begin with. Hard to say. So there were some jokes there. Oh, see. tape is so strong that actually it's attached to the wooden cabinet with tape, and it never ever fell off, which is ridiculous. But yeah, that thing is amazing. So, but because it's wood, I was able to remove it without destroying the cabinet. So at least something. No, that's my office. Never mind. Let me show you. Was there anything else on that? Yeah, that's okay. So that's the beginning of storage. That's what it looks like when you order 100 SATA cables. This was a joke that was going on internally, which was that in Star Wars sometimes there are quotes where Han says that Chewie says that something looks like a Banta's butt. So the comment was that Chewie was saying that my networking work wasn't so good after the switch failed. So storage. We have 48 drives, so you go on eBay and you order 100 SATA cables for $3. Actually, I thought I was ordering 10, but I ordered 10 packs of 10. So when it arrived, it was this huge box, and I was like, what is this? And then there are 100 SATA cables. And I was like, I just paid single-digit number of dollars, including shipping from China. What the heck is going on? So I used the ones I needed, and then I put the other ones on MIT reuse because I wasn't going to explain 100 SATA cables to my wife. So that's the beginning part. Then the drives you kind of already seen, and then we had the original set of drives that came from my V1 configuration. Then when I decided Ceph is required, everything has to get full of drives. So the cabinet is fairly heavy, as you can imagine, with all that. And I found that someone on eBay was selling a few Sun hard drives. And I started, I guess my marketing side took over, and how can I make a large number of hard drives look really impressive when there are these different shots? There is one, oh, will it look more impressive in a matrix or in a line? In any case, this box full of hard drives arrived, and that was another 24 drives, the other half I needed. Because they were being retired by someone that was killing their Sun hardware. These have some firmware, but they behaved like perfectly normal SATA drives. And it was like 20 drives for, they were used of course, but they work fine. It was 20 drives for $199 or something like that. So in terms of populating the drives, and it was awesome, which is kind of why I don't keep track of the drives anymore for the, yeah, it was basically irrelevant.
Yeah, well, it depends on how much storage they have.
They're not too big, but I wasn't going for, see, the majority tend to be around 250. There are some 500s, which are the newer set that I bought new when I was starting to build things. So let's see if, so that covers the storage. Let's see if there is anything left here. There's a lot of connectors and a lot of labeling, but that's about it, I think, for the storage side. Yeah, these are the sleds, nothing that we haven't covered there. There were other considerations that we dealt with when we made the first version, when I made the first version, which was or issues like we didn't like fast port back then, because with certain network configurations, fast port would confuse the heck out of the bare metal provisioning. But I'm not using bare metal provisioning here, so I don't have that issue at all. Plus now I've completely separated the networks physically, so that doesn't seem to be an issue. Now here are the power side. One thing that when you're trying to design this neatly gets funny is, see, these are all the original cables, they're all 6-footers. So I put them in and then I go, what am I going to do with all this cable? Which is why I started designing the cables so that it would fit in a smaller space. But even then, there are things like, this is a straight cable, like most of them. For the ones here in the corner by the cable tray, we had to get corner cables to make it work. So it's an interesting design problem. Ah, there we go. That's there is always something more to be designed if you want to make it look neat. I think now it's fairly complete in that sense, but even now as I'm building it into the fourth configuration, I noticed that there are some things that we could do more, like the gateway, for example, is a single point of failure. There is a single gateway. It's not rated. That is also a single point of failure, and it's unnecessary. I could have built that one rated, but I didn't think of it. But there is only so much time, and there is diminishing returns at some point in what you're spending your time on. Let's see, this was the cost for the old version, which is pretty much the same, minus the switch. The PDU becomes cheaper. The switches, I didn't account for the switches. So, did I put the number? GS10 something, 165, I think. So for the switching, there are 3x Netgear GS1 something, which is the 1 gigabit, the 1 gigabit 16 port switch.
Sorry, 10S.
10S?
Yeah, or 105.
Oh, you're reading my writing there, but I think that's wrong. GS105 were the small ones, the ones with 4 ports. The one with 16 is, I'm not sure, 116 maybe, just guessing. These, turns out that buying them used is not a good idea, and these are more than $100. So let's say that they're $100 if they're on sale, but it's not easy to find them for cheap. And given my experience with the failing one, I wouldn't recommend buying them used. So that pretty much puts the budget for this cluster around $3,500 to $4,000, which doesn't make it cheap, but it's a 12-node cluster that really resembles a public cloud topography for less than $4,000, which, I mean, if you're buying real servers, you can buy a single real server for $4,000. So it is not bad as a simulation. Of course, there is the completely opposite end of the spectrum, which is cluster 4, the one that I didn't bring anything about here, which is building a cluster with 5 or 6 Raspberry Pis. It's like $150 in hardware, let's say $160. Even if you throw in a fancy case, it's going to be another $50. You can get a plexiglass case to make it look nice. There are designs where you have a little power controller that's made specifically for Raspberry Pi, and that has the power comes out of USB, so it has 4 or a larger number of USB ports, and you can connect to it using the I2C lines, and you can switch power on and off. So you can actually have single point control for the entire cluster. So you can build a Raspberry Pi cluster with more than 6 nodes and fit it in a few $100s. That's probably the lowest that you can go. You can also get fancy. I mean, there are bar graph extensions that go on the bar graph visualizations that go on the I2C of the Pi card. And that looks spectacular because you can do something like top on each board showing on the LED line. For demos or for booths, it looks really cool. It's like, ooh, what is this?
What about the one where it has a Raspberry Pi inside the controller that's controlling the controller?
I haven't seen that one. But there was an announcement 2 days ago that NATO has adopted an underwater modem standard for communication with autonomous submarine, AUVs, autonomous underwater vehicles, and that this underwater modem, I mean the communication protocol, not the modem, is running out of BeagleBone. So it's these little SBCs are everywhere. Of course, that's not their production one or mil-spec one, but the prototype was made that way. And they were very public about it, which is kind of cool. One thing that the network lost from my V1 or V2 version to the V4 is that I'm not doing any pixie on this network. I could because I can segregate it with the head node. I just I'm not bothering with bare metal provisioning because on the old product on the old configuration it was interesting because Canonical Ubuntu had this new MAS bare metal provisioning thing, and so it was interesting to try it and to figure out what the problems were. Now it doesn't seem to be as important to have bare metal provisioning, so I'm not bothering because you can easily spend more time on bare metal provisioning than on the cluster itself, despite all the wiring and cabinet building and everything that I did. Bare metal provisioning is the thing that gets messed up more easily than anything else. So on the OpenStack side, I would rather spend time figuring out neutron and network configuration than bare metal provisioning at this moment. I think we covered all of this. We covered the costs. We covered the hardware specs. So I think we are done. Any questions on this one?
How much does the whole thing cost?
I would say between $3,500 and $4,000.
What is the price of the orange box you broke like a few years ago?
The price
orange box?
The orange box. Oh, the orange box that I brought in a few years ago.
Of course, that was a canonical thing, not a Red Hat thing.
Yeah.
It was custom made.
There was no price tag on it?
Well, internally we knew how expensive it was. It was between $12,000 and $16,000.
Was that a product you sold to customers or just something you used internally?
No, it was something that we used to use for everyone that was a sales engineer had an orange box assigned to them. So
that is horrible, by the way.
They could demonstrate orange live. It was very nice marketing-wise. It was insane on the sales engineers. They hated them. They were dragging these things everywhere. So the SAs didn't like them, but the customers found them fascinating. So as a marketing gig, it was a very nice idea. What else? So the fourth cluster, which I haven't covered, is actually much simpler, and it's the dish rack cluster. And I'm going to save that for the next time I come, but I'm going to give you an idea of what it looks like. In boxes, it kind of looks like this. I use desktop processors again. That's one part where to keep costs down, you have to accept that. And so these boards are also desktop boards. I didn't use server boards. There is no IPMI. This is meant for Docker, so bare metal I didn't care at all for. So I just went with a desktop configuration that I liked and that had ports all on one side. And then I got this $5 dish rack thing while I was building it that now is going to be there forever because it's so popular with people upstairs. This is how the boards look like. We can dissect this next time, but the idea then will be, next time I do it, this one will not be about hardware. We'll be talking about Docker proper. We'll be using the cluster because we'll be looking at Kubernetes or Swarm. But we'll have the live cluster to do it because this cluster cannot be lifted by 2 people. But the other one, but this one, and this has 12 nodes, and it has 48 drives. This one has only 1 SSD per board, and it has 7 nodes. And it does not require me to ask Jerry and others to come down to grab the hardware. It's just a 1-person operation. So it's, in that case, in that sense, it's more portable. Obviously, it's moved up the stack. We're not doing any of the infrastructure considerations that were so interesting dealing with OpenStack, because that's what the user sees. I mean, by user, I mean the operator in this case.
It probably helps if it's small enough to fit on something like this.
Yeah, and it really fits on, I had it on my desk. It's about this wide, no problem. Mm-hmm. You're eliminating all infrastructure considerations, saying someone else is taking care of it, which means you're putting on blindfolds, but I guess I'm entitled because I spent so much time on the other cluster. And I can use this just to look at container end up, so orchestration layer end up. So that's going to be what this cluster does. And I don't think I have the, yeah, I guess I don't need to give you all the details here, but this rack has a shelf that folds out on the back, and the power supplies are sized to fit in there. So there'll be 7 power supplies parallel to this. And then the SSDs are obviously very light and small, so that's not a problem.
You should you should protect the end so that like something comes along and hits it. There's a
That it
little
doesn't
bit of
dump
protection, and just do like 2 shield-shaped things so that it really does look like a dish rack.
So there was the idea that I would just paint this bright red and make it very brand compliant, but I like the color of unfinished wood, so I'm sticking to that for now. This is 6 nodes, by the way. I added the 7th because the original plan here is there are plans for these boards to fit in an IKEA cabinet that has 6 drawers. Each drawer becomes 1. There are plans where you cut with the laser cutter. You cut acrylic of the same color for the front, so you can put temperature readouts or other readouts in the front of the drawer, and in the back, so that you have vents for air to go in and out for the power supply, which is also sitting there in the drawer. So that is a very nice design, and this board is compatible with that. And so, since that design entirely depended on having the exact type of board, I wanted to have a backup in case a board failed. But for now, I guess we'll be on the rack, so that doesn't matter. And we'll see. We'll talk more about this when we do a Docker talk, whenever I have time for more. All right. Any other questions? Otherwise, we're going to call it a night.
So in the second on the second cluster, you said that you were gonna migrate to Ceph.
All right.
Out of the 12 nodes, are you gonna make all of it as storage, or it's are you gonna split it in computing and?
I want to consume the storage from OpenStack. So the V1 configuration used to be that there were 6 nodes up top that were, well, the V1 configuration wasn't laid down like this, but it doesn't matter. There were 3 nodes that were storage. There were 3 nodes that were Nova, so compute. So this was Nova, and this was a bunch of storage services all living here. The 6 above were used as clients. So one was running MAS, another was running landscape for management. So one was bare metal provisioning, the other one was management of the system, and a bunch of other things for simulating loads on the cluster itself. So the OpenStack thing was fairly thin, but you also have to consider that this was not hyper-converged, so other services like Keystone were living up here. The other nodes were basically, there were a couple of canonical Ubuntu-specific services, and 4 nodes that were OpenStack services that were not compute or storage that would also dub as workloads. While the V4 is looking like this. There is, yikes, I cannot draw anymore. There is this node, which is the head node, which is basically the gateway to the outside world for all networks, and it's also the management node, so any management infrastructure would live there. I'm not planning to use Red Hat Satellite or anything heavy like that right now, so it's plenty for this to do all the network routing and additional services. But when I log in somewhere to manage the cluster, I tend to log in there. That's where the monitor is attached. There is a second monitor that I use to just install the other machines. I move it around. These 5 nodes here are Ceph, and that's a 4 or 5. They all have 4 drives right now, and I'm redesigning them to have 5 drives each, so that one is the boot drive, the other 4 are OSDs. So we have, I haven't made allowance for Ceph journals because, come on, these are Athlons, where SSD journals are wasted. So it's all spinning disk, low performance, but the CPU couldn't give us high performance anyway. 1 disk per OS, and then 4 disks per machine for storage. So 20 drives attached to Ceph up here. And then down here, there would be 1 Nova controller. I'm not going to go HA, but I may have to spread it across nodes, because in Red Hat's configuration, a lot of services are co-located with the controller. A lot of things that don't need to scale out, like Keystone, or the Ceph monitors usually are co-located with the controller. The controllers tend to be very beefy nodes in Red Hat's reference architecture, which makes it sensible to co-locate things here. Problem is that my nodes are all looking the same, so I may have to take more than 1 node for the Nova controller. Not for HA reasons, just but to spread the load. So we'd have 4 or 5, depending on how things turn out, for compute. And the storage configuration here is obviously the VM storage. All the storage is coming from Ceph. Swift is coming from Ceph through the compatibility interface. Block storage is coming through the RBD Cinder driver. All the storage is coming from here, except the boot volumes for these. They are local to Nova, and those are unnecessarily, frankly, but they are they're mirrored with RAID, because why not? Once I spent the time to set it up and I have the drives in there, I may as well not use it if a drive fails. So that's how it's looking like right now. Of course, I can decide to make it more complicated, but I'm running out of options for that. So I need to build the next cluster and stop fiddling with this one. Anything else?
Okay, thank you.